Yeah, that's great. I just rebooted. Okay, sorry guys. I don't know what happened. So let's continue. So let me start from scratch. So uh, we will talk about immutability, and we had a few webinars before about immutability, and I wrote a number of articles about that. So I guess you all know what I'm talking about. Now we will try to analyze how we can build everything immutable, and whether we can move from a mutability zone to more like to where we have more mutability. And because it's kind of, for me, I think it's kind of a gray area. It could be the gray area, so it's interesting to discuss where we're standing and what we can do. So I wanted to show you the code. So let me share it again. Let me share it again. Let me open it because I rebooted the whole thing. One sec. And here we are. So let me share the screen. Here we go. So I started with an example. I started with an example of a mutable code, which is terrible, by the way. It's a formatter. It's more like a utility class, but it's kind of typical for Java and many other languages. Yeah, so you can hear me now. So it's a temperature formatter. So we have some kind of a private property, private attribute here, and we change it through the setter, and then we want that class to format it for us in Kelvin, for example. In order to do that, we need to first of all create an instance of this formatter. Then we inject some number in there, and then we format it. We call this procedure format, and we get the result. It's really typical mutable code, which has this setter in order to change the value, which the procedure will later manipulate with. We talked a lot about that. It's just a pure container with data and procedures attached to it. No need to discuss it again. I hope you understand this is just a bad idea to have this code. The better idea is to make it immutable. The immutable code is much more elegant, much more, much shorter, usually much safer, and everything. So the really immutable code would look like that. There would be the temperature as a class, and there's going to be the final attribute inside, which is provided through the constructor. It's encapsulated. It's never changeable. Nobody can touch that. And then we have the method formatted, which, well, I changed the name of it because it was format before, but since now we're talking about objects, then it's better, instead of calling it format, which is kind of a name of a procedure, it's better to give it a name of a thing, which is returned. So it actually returns a formatted temperature. And then when we need to do that, we just create a new object temperature. We encapsulate the number, and then we call formatted. So this code is shorter. This code is shorter as well. There are many benefits of immutable code. First of all, you can find them on the internet. But first of all, it's thread safe. It's side effect free. The code is smaller. The code is more cohesive, and the amount of code you need to write in order to use that immutable class is smaller comparing to the one we had before. It's clear. It's obvious. We know that. And now the next question: what will happen with this class if I change it this way? Because look, now let's go through it again. So now when I encapsulate, when I create an instance of this object, so here's an instance, and then I call formatted. So no matter how many times I do that, it's always going to be the same. So A and B, they always will be equal to themselves. So they're the same values here, no matter how many times I do that. If this value is the same, then the result is the same. So it's perfectly immutable, and everybody expects it to behave like that. What will happen if I put something like that here? Is it still immutable? So every time I call this, so now A and B, they most probably will not be the same. Because we cannot say that the temperature is exactly the same every time. So yes, it was 120, but because of some logic inside, we can't say it's 120 all the time. So we have to say plus minus some random number. Is this class still immutable? We still don't change the value in here. We still don't touch the encapsulated attribute. We don't allow anyone to change it. We don't have any setters. So, but the result of this method is always different. So every time we call it, it returns something else. I think that this is still a mutable class, but it's not a constant anymore. So the previous one, without this code, without this, like that, it was a constant. So no matter what happens, it always behaves the same way. So the behavior is the same, the state is the same, the identity is the same. Like in any object, we have the identity, we have the state, and we have the behavior. So in this case, three of them are exactly the same all the time: state, the identity, and the behavior. But in this case, the behavior is different. So the state is the same, the identity is the same, it's still the same object. So the temperature is the temperature. The state, encapsulated state, 120 is the same. It's 120, 120, but the behavior is different. I believe it's still immutable. I think it's still immutable, even though for many people who, like for many programmers who used to think that immutability is about constants, about being constant and being completely unchangeable. I mean, not just completely unchangeable, but completely repeatable and completely the same every time you call it. For that programmers, this class looks less immutable or sometimes not immutable. I think it's still immutable. Let's go further. Let's make one more step further. Let's say that I don't get the temperature from here, I get it from the file. So let's say I encapsulate the file here. And in order to get the temperature, I will, somehow download the content of this file and return it back. So in this case, is it still immutable? Well, probably. Let's say we do this. And then I don't remember something like that. Doesn't matter, but we just save to the file, we save key. So what do we have now? Is it immutable? We can create a temperature and we will encapsulate something like that. And then we'll say X update and put 120. And then we say X formatted. And then we say X update and put 50 here. And then X formatted again. Is it still immutable, or we have a mutable class, a mutable object right now? I think that it's still immutable because it still doesn't change the state, because the state of the object is still the same. We still encapsulate the same file. We don't change the file. Nobody can call, nobody can say set file here. If that would be the case, then yes. If you change the file and then change the value here, then yes, that will be a mutable object. But we can do that, so we still don't change the state. Remember, any object has an identity, state, and behavior. So in this case, the identity is the same. I mean, the temperature is the temperature, so it doesn't change itself. It's the same. The state, which we encapsulate this file, is still the same. What's inside that file? It's a different story. It's the behavior. So we can update that file, we can download from file, we can do something with the file. So the file there is mutable, yes, but the object, the temperature, is not. The temperature is not the file, it's a representative of a file. So if I am the temperature, then I can't really guarantee that some file which I represent, I don't even know what the file is. I just have some object of a type file, and I just encapsulate it, and I know how to get something from it. Well, in a good Java world, that would look like that. We don't have that good Java world, but it should have. We would, in an ideal world, that would be like that. So I don't know. I don't really know what the file is. All I know is that how to call this method write and how to call the method read. Or even in a better world, we would have like that. That would be perfect. I would love Java if it would have that, instead of this utility classes and utility approach to loading and writing files. So let's say we have that. So I as an object, this temperature, I don't really know what's there. I just represent the file, and I'm immutable. I never change. I never point to any other files. I don't allow anyone to tell me that I'm working with a different file now. I'm always working with the same file. So I think that this class, this object, is also immutable. It is still immutable, even though for many of you, for many programmers, it may look like mutable. Like, look at this code. So we created something, and then look, we just update, and then we call it, and then we update, then we format it, and it behaves differently. And maybe somebody here will do the update somehow else through the file system. So maybe another update will happen. And then maybe I will say update 50, and then the update will happen here, and the formatted will print me 80. This may also happen, because I cannot guarantee what happens in the file system. All I can guarantee that I'm still pointing to the same file, that I'm still working with the same file. It's still the same file. It's the same file here, the same file there, and I can guarantee that nobody from another thread somewhere will do this. This will not happen. This is my guarantee to you. This will never happen. That's the only guarantee I have. So I don't guarantee that this will not happen, because I don't know what the file system is. Where is it? How it's managed? What is this file? It doesn't matter. I'm still immutable. I believe so. That's my understanding of immutability here. And let's make one step even further. Let's say that instead of a file, we have let's say we have something like that. I'm making one more step further to confuse you even more. Let's do it this way. I guess you know what this class is doing, right? Atomic integer. It's just a holder. It's a thread safe holder of an integer. And then when I say update t, I'm doing this. What do you think about that now? Instead of a file, I have just a piece of memory, because this atomic integer is basically an object which helps me to work with 4 bytes in memory. That's all it does. So I can set that value in memory, and I can get that value in memory. So how is it different from the code we had before? We had file read or whatever here before, and we had file we had file write here, and we had file read here. Now we have basically this one means memory write, and here we have basically memory read. So how is it different? Why file is different from memory? And here, why file is different from memory? What's so different in that? It was okay for a file. Well, let's assume that we agreed about the immutability on the previous step when I showed you the file. So why can't we agree that that it's immutable here as well? Even though many of you would say that, hey, it's mutable because we changed the memory. It's just, you know, what's the difference between this update method and set temperature, right? So you may say, hey, that could be like that looks like a setter because we basically change the value of that 4 bytes, but in memory. So that could be the question. And I think my answer is that I don't see a big difference between the file and the memory. Because for me, if I am an object temperature, then for me, this thing I encapsulate, it doesn't matter for me whether it's 4 bytes in memory or 4 megabytes on a file system, or it's something else. All I care about is that I encapsulate something and I represent somebody, and I never change that somebody. I mean, I never change the location of that somebody. So nobody from here can say that X, I will set that atomic integer or whatever, like that, to something different. So nobody will make me refer to somebody new. I'm always loyal to that memory, to that 4 bytes in memory. That's the whole point of immutability. So immutability is not about being a constant. It's not about always holding the same value, always being the same, and always preserving the same behavior over the entire lifetime of the project, of an object. That's not immutability is about. That's just a constant. It's just a corner case of immutability, which we had before. So that's how we started, when the temperature was just a constant, which was able to format itself, and that's it. But now we have a temperature which is more powerful, but still immutable. And it points to the piece of memory, just like it points to the file. So my point is that the file and the piece of memory is exactly the same things for an object. So for us, for this temperature object, it's exactly the same to work with the file or to work with a piece of memory. As long as this thing is final, as long as I'm always working with the same file, I'm always working with the same piece of memory. If that's the case, I'm fine, I'm mutable. And if you look at that, and if you look at this class, it does look like it looked like more or less like a normal class, which doesn't look scary as much as, you know, these constants everywhere. Because I got a lot of comments on the blog after the articles I published about immutability, and many people were saying that it's impossible to write the software where all my classes and all my objects are immutable. It's just impossible, because, you know, we're dealing with a lot of data. For example, we cannot make my class whatever. For example, if we have only constants, then I would have something like that. Let's say the list, whatever. So we have a list of items, and the A and the B and the C. And then I want to add one new item there. So basically, if everything is a constant, then I cannot do anything with this list except like this. I will have to do that. So I will have to change the list. I will ask that list to add one more item and return me the list number 2. And then this list number 2 contains 4 elements, while this list contains 3 elements. And it's really difficult in modern systems, almost impossible, because if there are just 3 bytes, it's all right. But if there are 3 megabytes of data, then the current hardware architecture and our languages are not really ready for that. They cannot make that. They cannot copy this data so fast. So it's not possible. So that's why people do like that, and we just add one more element to the list, and the list mutates somehow. So it changes the content, it changes what's inside. So I think it's perfectly all right in this case. So the list, we can still call this list immutable. It's not constant. It's not exactly, it's not constant, it's immutable. So I'm trying to define 2 names for these 2 different concepts. The constant is a constant, the immutable is immutable. So here the list is still immutable because it's still the same list, and it still points, well, probably it still points to the same piece in memory. If, let's say, we create a list, and let's say we create a list and say, hey, you're gonna have 5 elements inside, and then we say A, B, C, D, something like that. So when we create that list, it basically somewhere inside it makes probably some final. It's got the private final attribute, which would be called memory of size 4. So when we create a list, inside the list, it creates a piece of memory, and that piece of memory is ready to accept for pieces of data or whatever. And then we add, and every time we add, somewhere inside it does M, put, I don't know, position 0, A. And every time we do that, the list stays the same because it points to the same. It points to the same place in memory. So the list is immutable, even though we keep placing new elements in there. We keep giving it some new information. We basically calling the update method, just like here, just like we did before. We said update, and we gave some value, and that value went to the file. But right now we don't have the file, we have a memory, and we keep putting the data into the memory. So for the outside world, for us here looking at this code, it looks like we're working with something which is kind of mutable. But I'm asking to start thinking about that less than stop thinking of black and white. So we shouldn't say that this is mutable list. The list is mutable because it doesn't do like that. Because the pure immutable, if the list would be constant, then this code above would look like that. List, and then we would say list 2 equals to list add. Just like that. That would be in that case, the list would be constant, because we would have to always change, always create a new instance of this object in order to do any modifications with it, and to make it sure that would look probably like that. Same code. So this code is when we are working with the constant. This code is when we're working with an immutable list, but not a constant. I cannot show an example with the mutable list here because the list is not really good thing to to give some example of being it completely being it mutable. Actually, I can't think how to in case of list, that would be probably difficult. Maybe, yeah, I don't think how to do that. So that's my point. And then, so let me try to finish, and then we'll discuss, because I see you have questions. And now the main question, which I wanted to address today, is how do we draw the line between making everything constant and making everything immutable but not constant? So which kind of design I should use for my temperature? This one, or I should create temperature in a constant way. So what's the right approach? Because in this case, well, I can do it this way, or I can make temperature constant, and then in order to change it, you will have to always create, every time this update method will return temperature, and then you will have to, to every time to get a new object when you need to update it. It's possible to do it either way. Make it immutable or make it constant. I think, I don't have an exact answer. I was thinking about that, and I can't find an answer which would give you the instructions for a lifetime. I just think that the more constants we have in the code, the better. So the more code you can design without keeping your objects constant, the better. So definitely for small objects like temperature, like I don't know, some really small objects which just hold one attribute or whatever, just really like small pieces of which encapsulates a small pieces of data and all that thing, I would recommend to stay with constants as much as possible. But the moment you realize that for different reasons you just cannot do that, then you can move to immutability and start using the code like that. Start being like that. So in a few of my projects, for example, I have lists like that. I have lists which are completely immutable, and in order to create a new list, you have to, which are constant. So you have to call this like methods, and I don't call them add, I call them with. So you always have to do like that. And it's for small data structures, for small pieces of data, for objects which are not big, this is really convenient because for many reasons. Because first of all, they are thread safe. This code is not thread safe. This code is thread safe. So in this case, we'll lose the benefit of constants, which is thread safety. So in this case, if I add A, B, whatever, and then here some other thread says list clear, for example, then here my result will be really unpredictable. So I'm expecting here that the list size is 4, but because another thread did this, my list size will be 2. That's kind of weird, right? So that will be difficult for me to work with this list. I need to find a way of somehow to protect it against, how to deal with multi-threading and everything. In this case, it's not going to happen because if I give this list to another thread, then this thread will never be able to change it, because no matter what this thread is doing, it's always going to create its own copy of the list. So my list is going to be always my list. So no matter who is touching it, no matter who is reading it, it doesn't matter. No other thread can do anything which will break my logic. In this case, it may happen. That's the first problem. The second problem, of course, is that it's not side effect free. Again, if I give this list to some method, and I say, for example, I call this one and I say list print, then I don't really care what this method print is doing, because it cannot break anything. All it can do is just create a copy of the list and then try to break things. But if I give this list to the method print, and then somewhere inside this method, for some reason, I don't know, it will do this, then the list will be returned here, and it will contain 5 elements for some reason. So I was not expecting that. I was just calling print. And because the code inside print did something wrong for some reason. I don't know for why, but it happened. So it put another element in there, and this is called side effect, because I was not expecting that. So my expectation of the method print is that it will just print, but the side effect is that it puts some new element in there. So here the number is going to be 5. So is it possible to prevent that? Yes, it's still possible. For example, we can say here, we can wrap them from modification. So we can say don't touch list. So we can do it like that. So we give it a list, we decorate it with the don't touch list, and then nobody will be able to add anything. And if they try to do that, then the exception will be raised. Here we don't need that. So here we can be completely safe. We can go completely, you know, we can do anything, because we know that nobody can break our structures. Nobody can touch our objects in the wrong way, because the moment they want to update, they have to create the new instance, the copy. In this case, it's not the case, so that's why we need some decorators, some protectors. If we want to be safe, for example, then we will need to, I don't know, for example, let's say I want this object to be thread safe, so that the thing which will happen here, another thread will do this, another thread. And I wanted to prevent, I had it in one of my projects just a few weeks ago, I had that problem. What I did is, and I created the decorator, and I called it this way: list new transaction. In my case, I called it sync list. So I decorated like that, and then I said, and this sync list introduced one more method, and I said start transaction. And then here I said list finish. So and then I did the same sync list. I did another thread here. All threads are actually, well, yeah, I didn't do it here. So I gave this. So now my list is always synchronized. So which means that if the sync list knows, well, it's a transaction thing. So it knows that unless the start is called in the current thread, then you cannot call add. If you call add here, then there's going to be an exception. Not an exception, sorry, it's not an exception, but I'm using this, the semaphore in Java, which will, so your thread will be just staying and waiting. So when you call list add, then your thread is blocked until I call finish here. So I acquire the semaphore here, and then I release it here. And the moment I release it, then another thread can start working with the list. So you see, I can do some manipulations with that in order to protect my structure. And it's not really, it's quite elegant, because they're still, you know, they're still normal objects. They're not mutable. They're still, you know, properly designed. So that's why I can decorate them, and then I can rely on them, because they are really immutable inside, even though they allow modifications of the data structures they encapsulate. So that's what I did, like synchronized list, which allowed me to work with, you know, multiple complex objects, which were kind of, you know, which were allowing other objects to modify them. And in my case, they were not the list. It was actually a representative of a file. So in my case, it was, I called it an item, and it was something like that. An item which was pointing to a file. And then my logic was here that it was done like that, like lock it or get it, and then the thread starts working with it. Do some modifications to the file, f, write, whatever, some text, and then item. Yeah, it was the item was. So it was a little bit more complex. So that was not a file, but some resource. I call it resource, and then you can write to the resource, and then you have to close the resource like that. So, but when you write to the resource here, you don't want anyone to do the same. You don't want anyone to do get again here in another thread and start writing to the same resource, because it's going to create the mess. So you want to lock that resource before, well, right after you call get and before you call close. So when I call get, and that's why I created the synchronized item. So when I call get, the synchronized item understands what's going on, puts the lock into the semaphore, like locks the resource. And when I call close, it returns back the resource and removes the semaphore. And then multiple threads can work in the same time with the same item, with the same file. So they're all in parallel. They get the access to the file and return the access back. So I can do that. It's still immutable because I still point to the same file. So nobody can do something like that. That would be a serious violation of immutability. That's a serious problem. This is mutability, and this should not happen in object-oriented world at all. So that's a big mistake. But the rest is just purely fine. So I can get the access to file, I can change that file, I can return it back. I'm still working with the same file, but I cannot do this. I can never change the state of my object. I can do whatever I want with the behavior. I can make that behavior completely different, but I can never change the state of the object. So I'm finishing. So my point is that you should always try to you should always try to work as much as possible with the constants. Because if you have just immutable objects, then you will need some kind of that manipulations in order to protect them, in order to help them become thread safe, side effect free, all that things. So, but it's not always possible. So this I'm not using that as much actually. So I'm using this stuff for really small objects, like like basic objects, and which are really have to be immutable. And this stuff I'm using for things which are bigger. Okay, I'm getting back to your questions. We got a few. The question first: how would you describe mutable object? Well, the mutable object for me is let me remove the code. Let me stop the share, the screen share. Yeah, you can see me now. So the first question. So how I would define the mutable object? I think mutable object is the object which can change its state, which allows other objects to change state, which basically has setters. Yeah, that's the answer right here in the chat. So setters that change the state. That's exactly my answer. John, thanks. Why, another question, why assume only setter change state? Well, it doesn't matter how you call the method. You can call it just a method or whatever, but the point is that it changes the state. So it changes the object which is encapsulated inside. Another one, if file update is not thread safe, that will make our code also not thread safe. Exactly, it's exactly the good question like I just demonstrated. So if the file point update, yeah, no, sorry, I didn't understand the question. So yes, if the file, we encapsulate the file and the file point update, the method update in the file we encapsulate is not thread safe, then of course our object is not thread safe as well. So if I encapsulate an object and that object represents a file on a file system and the file system is not thread safe, then of course I cannot be thread safe as well as an object, because I represent somebody who is not thread safe. So what kind of guarantee I can provide if that thing over there is not thread safe? If you want to make me thread safe, I would recommend to create a decorator around myself, which I would call like sync or safe, or like I just showed, like sync item I have. So just decorate a not thread safe object and make it thread safe. I wrote an article about that, which I'm going to publish on Tuesday, about how to convert a non-thread safe object to a thread safe. And I'll give a practical example there, which I'm just saying right now. So just decorate and make it thread safe. Well, a mutable object could be there is some suggestion. Let's see the code. Who uses this approach? There's an answer. I try to use it as much as possible. So I also try to use it as much as possible. So I don't have any mutable classes for for at least 2 years, and but I have many of these things which are not constants, and it's perfectly fine. I don't feel any trouble with that. Functional programming already found a solution to immutable list. It's called persistent data structure. Persistent data structure. I'm not sure I know much about that, but in functional programming, yes, we have immutable lists. Everything is immutable in functional programming, as far as I know, all these data structures. So yes, maybe we can inherit something from them and learn something from them. But in Java, I just use what I showed you. Yeah, exactly. That's exactly the answer goes right after this question. So the goal is not be religious about nor competing with functional programming. It's just about forcing us to do object-oriented right. Exactly. I'm just trying to show how to do in Java to do it better than we do in most cases. Yeah, there's a question about my disagreement with David West on immutability. That's a good question. So I probably you saw the interview of I talked to David West, the author of Object Thinking book, really good book about object-oriented programming. And then I asked him about what he thinks about immutability, and he said that that objects around us in the world, they're mutable. So that's why in object-oriented programming we have to be mutable as well. And I totally agree with that. I think it's just a disagreement about the definitions. So he's saying that don't be immutable, and he means that we're talking about. I think he meant constants. So he said that don't make constants. Don't make this everything as a constant because the world is mutable. And I agree. You can't just make everything constant because the bigger your objects are, the more necessity you will have to make them. To make their behavior more advanced than just returning exactly the same every time. Like constants, their behavior, like in numbers, for example, or strings, or this temperature, they always return the same. How many objects like that we can have in our software? Just a few, types of that objects. Just a few objects. So I totally agree with David. So we have to be. Our behavior has to be more advanced than just constant. But I would still call it immutable. I would still call the design of our objects immutable. So that's my answer. I think we're on the same page with David. I probably skip a few questions. Sorry for that. There's some comment about Haskell. It's a good language. It's still my plan to learn it and try to write something in it, and then I'll probably be able to comment. There's some discussion about something. Okay, there's something about something else. People talking in the chat while I was showing the code. Okay, we have just a few more minutes. Yeah, that's a question about the code I just showed. The question is state of sync list changed when someone takes the semaphore? It's a good question, and the answer is no, because the sync list, which I demonstrated just a few minutes ago, the sync list is just a decorator of a list. And the state of this sync list is a list as a collection of, first of all, is the encapsulated list, and then a collection of semaphores. Or maybe just one semaphore, actually one semaphore, not a collection, just a semaphore. So inside, let me open the code. I'll take a look how it was done, because I did it like telling you 5 days ago. Let me check. I'm not going to show you that's like commercial code, but yeah, this is. Yeah, it's one semaphore, exactly. So what the sync list has, or sync item in my case, it's the encapsulated item and the semaphore. So this is the state of a sync item. Two things inside, the original item and the semaphore. And every time we get calls there, the semaphore works somehow. So there is some mutable thing. I mean, there is some piece of memory inside the semaphore. Of course, that's how it works. But for me, for the sync item, it doesn't matter what's there because I always point to exactly two objects, the original item and the semaphore. And I never betray them. I never point to somebody else. So my state never changes. Even though every time requests come to me, I call the semaphore and the semaphore does something inside and probably changes the situation. I mean, the behavior of semaphore is active, is not constant. It's, you know, it's, I don't want to say mutable because I don't think behavior can be mutable, but the behavior is not dumb, it's not primitive, it's complex. It does something for me. But I never point to another semaphore. I always point to the same semaphore. One more question, and I think we'll finish. If list's entire state is its contents, so that when you ask if a list is equal to another list, it compares contents, doesn't that list still suffer from mutability? I don't think that the content of the list is its state. Like, look at this example with the file. If I'm an object and I'm temperature and I'm pointing to the file, so the content of the file is not my state. My state is the name of the file. See the point, right? So when what's in the file, I don't care. It's not my state. It doesn't belong to me. It's piece of my behavior. So my behavior, when you come to me and ask, what's the temperature? I just go to the file, get the temperature, and return it back to you. So my state is the location of the file. The same for the list. So if you come to me and say, give me all the items you have, I go to the memory, to the storage in memory. I get what's there, all these items, and return them back to you. This is my behavior. It's not my state. My state is that location in memory. If we would talk about C++, that would be pointer in memory. That would be just 8 bytes pointing to the place in memory. That's my state. What's in that memory, it's not my state. It's just my behavior. I'm just transferring that data just the way I would transfer it from the file. Because immutable objects, they never change their state. That's important. That's what immutability is. So the immutable object never changes the state. And my state, in case of the list, my state is the location, not the content. That's what I think. So it's time. We just finished. Thanks. Sorry about the technical problem in the beginning. I hope that the content will be recorded and it's going to be live. It's going to be on YouTube in a few hours. Thanks for watching. See you next month, the first Wednesday of the month at 11 in the morning Pacific time. Thanks for watching. Bye-bye.